Hi, I'm Anon Chaudhary, an uprising sophomore in Monte Vista High School, and today I'm going to be going over the applications of derivatives, a continuation of last video. And this is going to be specifically in physics. So why don't we get on into our first problem? The position function of a particle is given by s, which is distance, is equal to t cubed minus 4.5 t squared minus 7t when t is greater than or equal to 0, t equaling time. And it's asking us two separate questions. A, when does the velocity reach 5 meters per second? And when is the acceleration 0? So why don't we just get on into it? Part A. Part A. Now we know the velocity is the derivative of the distance, so let's take the derivative of the first one first. So s is equal to t cubed minus 4.5 t squared minus 7t. We're going to take the derivative, so ds dt is equal to 3t squared minus 9t minus 7. And we know this is change in distance over change in time, so we can write it as velocity is equal to 3t squared minus 9t minus 7. Now it's asking us when it's going to reach 5 meters per second. So we can just input the value of 5 for velocity. So 5 is equal to 3t squared minus 9t minus 7. If you subtract 5 by both sides, we can make it a quadratic. So we can make it 3t squared minus 9t minus 12 is equal to 0. We can factor this into equaling 36. 36 we can make 3t squared minus 12t plus 3t minus 12 equals 0. This would equal to, if you take 3t out, this would equal to t minus 4 plus 3t minus 4 equaling 0. And we would end up with t minus 4, 3t plus 3 is equaling 0. And so remember, this is a value at which t could equal to 5. So we're going to solve for t for both. So basically t is going to equal to 4, because if it's equal to 4, it's equal to 0, or t can equal to 1. t can equal to negative 1. But time can never be negative, so we can already cross out that solution, and our value would be t is equal to 4. Okay, so that's part A. T is equal to 4. At time is equal to 4, the velocity will equal to 5 meters per second. Now it's asking us when the acceleration is equal to 0. So I shouldn't have erased the derivative actually, but no problem, we can do it again. S is equal to t cubed minus 4.5 t squared minus 7t. ds dt is equal to 3t squared minus 9t minus 7, which is equal to velocity. And we all know change in velocity over change in time is equal to acceleration, which is what we want. So we're going to take the derivative of this. So I'm going to write the velocity as v, so dv dt is equal to 6t minus 9. It's asking when the acceleration is equal to 0. So acceleration is equal to 6t minus 9. We're asking for when acceleration is equal to 0. We can plug in 0 for acceleration. So 6t minus 9. We can solve for t. So we can add 9 to both sides. 9 is equal to 6t. T is equal to 9 by 6. We can further simplify this to 3 by 2. 3 by 3 by 2 seconds. So that's when the acceleration would equal 0. And again, in this way we use the second derivative. First, for part A we use the first derivative. And yeah, that's kind of how you use these are the applications of derivatives in physics. I hope you guys enjoyed the video. I hope you guys learned something. Thank you for watching, and subscribe if you haven't already. Thanks, bye.